Greetings and a very good day to everyone here. I'm Tay Cze Shuen, the moderator of this forum. First of all, I would like to welcome you all to this forum presentation regarding the three methods for conservation assessment for the three species chosen, which are the palm civet, the phyton, and slow loris, as presented on the screen. Before this presentation begins, allow me to introduce the speakers: Krismini Rajah as speaker 1, Hildayani Habil as speaker 2, Khairunnisa Nazurah as speaker 3, Wahida as speaker 4, and Asma Najihah as speaker 5. Without further ado, firstly, let me explain about EOO and AOO methods for conservation assessment. The EOO, or the extent of occurrence, can be defined as the area contained within the shortest continuous imaginary boundary, which can be drawn to encompass all the known, inferred, or projected sites of present occurrence of affection, excluding cases of vacancy. As for the AOO, or the area of occupancy, it is defined as the area within a species' extent of occurrence that is occupied, excluding cases of vacancy.
I see, but how about the ENM and AUC? What do they mean?
Okay, ecological need model, known as ENM, is a class of methods that use occurrence data in conjunctions with environmental data to make a correlative model of the environmental conditions that meet a species' ecological requirements and predict the relative suitability of habitat.
AUC is the area under the curve and stands for area under the receiver operating characteristic, which is ROC curves. That is, AUC measures the entire two-dimensional area underneath the entire ROC curve.
As we already know and understand the meaning of every important term and the methods of conservation assessment, we will then start to discuss the ENM model, which is represented in a map generated from Maxent for these three species. So anyone have questions regarding the map?
Yes, I do. First of all, I would like to know about the map in the poster of palm civet. Based on the map, why there are more blue colors compared to others? Does the color indicate any meaning?
The blue-colored gradient means that the region has a low probability of the species that to be present or inhabit that area. Thus, from the palm civet map, we can deduce that the palm civet species might be rare or they might not inhabit the area, resulting in the blue-colored gradient presented on the map. This is because we can assume that the area is not suitable habitat for the species to inhabit or adapt in that region.
Move to the slow loris map. Why is there so much green color appear on the map?
Green color gradient indicates condition typical of those where the species is found. The slow loris is found in continuous canopy tropical rainforest. It is adaptable and can also live in the other types of habitats. These slow loris species are widely distributed and mostly found in Peninsular Malaysia. Although it is considered extinct in Tioman Island, records shows that the slow loris males still inhabit the island.
All right, so for the map of phyton, why are there a lot of red areas at Pulau Langkawi?
Okay, for the maps on Malayo Python reticulus, the area in Langkawi are almost fully covered in red color gradients. So this indicate that the red color gradients mean the region has a higher abundance of python species that were present there. And we also can say that this place or area is a suitable habitat for this species to survive or inhabit. And this is because of an environmental factor, as the Langkawi Island area contains many hills and forests that provide shelter and habitats for pythons.
So apart from that, the value of EOO and AOO also shows different values for each and every species, as you can see from the poster that presents. Poster of Python shows the highest value for both EOO and AOO compared to the other two.
Regarding of EOO and AOO, why is the area of EOO and AOO of slow loris low among these three maps?
The EOO of the species was about 82,000 kilometers square and the AOO was about 64 kilometers square. As can be seen from the result obtained, both AOO and EOO have the lowest values among the three species. So this shows that this species has the lowest area distribution in their habitats.
Pardon me, I also have another question about the second map of the Python distribution map. Why are the values of the AOO and the EOO in that poster of Python is the highest compared to the others?
Okay, based on this area, the EOO of this species was about 130 kilometer per square, and the AOO was about 136 kilometer per square. So we can see that both AOO and EOO have the higher value among the three species. So the higher value of AOO and EOO, it shows that this species has a higher area that is suitable for their habitat.
So to conclude Ms. Khairunnisa question, we can see that the species inhabit quite a wide range of regions compared to others, since the EOO and AOO indicate high values. Is it clear, Ms. Khairunnisa?
Yes, thank you for the explanation.
Okay, next, as we know, the status rate list of any species can be identified using both IUCN and GeoCat. So why are there differences between the status from IUCN and GeoCat?
As mentioned before, from the definition of EOO and AOO by Ms. Shen, we can know that the status of this species in GeoCat was identified based on the geographic range and the area where the species occurred, while the IUCN rate list status was based on the worldwide distribution that was published. So that's why the status shows different from the IUCN rate list.
Okay, moving on to the next point, it's about the AUC. AUC is a graph of species sensitivity versus average specificity of a species defined using predicted area and is almost universally used to assess the performance of species distribution model SDM. This AUC was determined based on its value and it has its own interpretation based on the range of values calculated. Now I open the table for any question about this topic.
Based on the palm civets map, it has the highest AUC value among those three species. So what does that mean and why?
Okay, the high AUC value for the map of palm civet actually means that it had a better performance of the model at distinguishing between the positive and negative classes and is considered in the good model category as it had a 0.833 AUC value, which is more than 0.81 compared to the other two species, which are in the moderate category. So in other words, AUC is a valid as a single threshold independent measurement of the model performance.
Okay, I have a question for Ms. Khairunnisa. From the palm civet maps, why is the civet species only occur at specific place, especially regions covered in red colored gradients?
Okay, as we know, every organism has their own unique and suitable natural habitat and ecosystem that's adaptable for their survivability. So from the palm civet map here, it is known that those red-colored gradient areas are the natural habitat for the palm civet. We can assume that the region has all the basic living necessities, like food resources, that influence the presence and abundance of the species to be found in the area. So that's why some specific regions have red-colored gradients. Did I answer your question earlier, Miss Farah?
Yes, you answered my question clearly. Thank you for your explanations.
All right, so we have reached the end of our discussion. So in conclusion, some organisms can be widely distributed and found everywhere, but some have their own unique and suitable natural habitat and ecosystem that is adaptable for their survivability, such as the palm civet in this forum. The map of palm civet shows a big area of the blue colored gradient, which means there is a big region in Malaysia has a low probability of the species to be present or inhabit that area. And as for the slow lories, the map show more green color gradient than other color. This indicates that there are conditions typical of where the species is found. And for the map of python, it can be seen that the species are mostly found at islands, especially at the areas in Pulau Langkawi, which are almost fully covered in red color gradient, indicating a high abundance of python species present there. The slow lories have the lowest AOO and EOO values and has the lowest area distribution among the three species, while the python species inhabit quite a wide range of regions compared to other species, since both of the EOO and AOO value is high. Moreover, the status rate list of any species can be identified from IUCN and also GeoCat based on different approaches. Lastly, the higher the AUC, the better the model performance. Finally, we come to the end of this forum presentation. I would like to close this forum by thanking all of the speakers for your participation in this informative and interesting discussion. Hopefully, this presentation will be beneficial for everyone. Again, thank you for your attention.
Thank you.